Okay, in this video, I want to briefly touch on a C++ language concept that's general and applies to any C++ class you can implement, and that's out-of-class member function definitions. It's a bit of a mouthful, so let me explain what that is. So let's say we declare some class T, and inside of it we have a member function. Well, up until now, every time I've declared a class and implemented a member function, I've just implemented that member function directly inside the class. But you don't have to. Just like in C, where you can have a forward declaration that you then implement later, member functions can simply be declared and then implemented later. And so by putting a semicolon here, I'm saying this is just a declaration, and I promise I'll implement it later. But by doing that, what we're really committing to doing is implementing that function outside of the class somewhere. That's fine. It's just that when we do the implementation later, the compiler needs to know that we're providing a definition for a member function, not just a normal global function. And the way we tell the compiler that we're creating a member function definition is by adding the name of the class in front of the function name, and then including the double colon operator in between the class name and the function name. So since this is class T and some function, then when I provide the definition later, I'm going to write T : some function. And if there were arguments, the arguments here would also need to match. And the return value that we previously declared, return type, should also match. So all of these things have to match up. And then when the compiler sees this, it's going to say, oh, okay, you told me there was this member function in class T. You gave me that prototype earlier, so now I see that you're implementing it for me. Good job. And it will actually know that this function belongs inside this class and provides an implementation for that function. Okay, so the key is we can declare a function in the class and then define it somewhere else by adding the name of the class followed by 2 colons in front of the name when we define it. Okay, this is the same symbol used for the namespace scope operator. Okay, but here it's not a namespace. It looks like a namespace, it feels like a namespace, but really it's a class scope in this setting. Okay, and it gets reused, and it kind of makes a lot of sense that it's reused because what we're saying is some function exists within T, and in this case, T is a class, not a namespace. Okay, so in summary, out-of-class definitions allow us to separate the implementation of classes into declarations and definitions. And this is very helpful later when we want to separate classes into header files and source files. And so a header file is something that might get included in a lot of places. And the source file is where the implementation really is that you have to compile and link together with other source code files in order to get a program to really work. And by separating these two things out, it gives us flexibility that we wouldn't have before. I want you to go ahead and see this because sometimes it's just easier for me to show you a function on a slide rather than showing you a whole class with a function inside of it. Now you'll recognize that when I say class name : function name, what I mean is that this is a implementation for a function that's part of a class, and that the class was probably on a previous slide. And now instead of showing you the whole class, I'm just showing you the function definition.